If we're thinking, I guess with sort of the security implications of using these AI-generated systems is a big question. We worry perhaps we're going to open up security threats. Clearly, AI opens up a whole new set of vectors, sort of reminds us a bit of some of the things we saw with databases. Things like prompt injection, and you see people doing these like weird prompts, and the models reacting in favorable ways. Once you start tying those into backends, things can be dodgy. Anyway, we're not here to hear from me. We're here to hear from André Baptista. So over to you, sir. Big round of applause.
Thank you, James. It's nice to see such a big crowd here in Portugal discussing so many interesting topics. So I'm André. I'm also known as OXACB on my socials. It's also my hacker handle. And I'm bringing you a security perspective on how we can use AI to hack stuff. And why is that important? Let me tell you a bit about my story. So I'm a co-founder of Hackian, but before that, I hacked a lot of companies worldwide, from Uber, Tesla, OpenAI, and way more than that. Even the Department of Defense of the United States and more, on live hacking events, basically. And there are so many vulnerabilities, okay? There are vulnerabilities everywhere. And it's not a new problem, but now that we are building faster, especially by leveraging, all these LLM models and so on, and vibe coding stuff, there were multiple situations where these applications got compromised, right? Because these AI models lack some security features. It's better now, especially if you see like Cloud Code, for example. You can do a security review command, for example, nowadays when you build your stuff. But still, in sufficient complex applications, you'll see that vulnerabilities are there and that can be leaking data. One example was an application developed by a friend of mine that it was very training on Twitter, and he built like an application for bug bounty hunters, and it was using Supabase and like some integrations, and it was leaking on a response PII, basically, from all the users, and the model didn't know about that when it was designing the system. So we co-founded Hackian to try to scale these the capability of solving this problem by autonomously identifying those vulnerabilities as fast as possible before the real attackers do it. So let me tell you some examples about on how hacking can be improved with AI. And hacking or penetration testing, who has a penetration testing background here? Anyone? Oh, we got a few ones, nice. But I bet that everyone knows someone or some company that had security problems, right? It's a problem that still needs to be solved. I also ranked on one of the top 5 risks by World Economic Forum this year for the upcoming 2 years as well. So hackers and security researchers started to use AI in order to automate their work, right? We know how to code as well, and we build our own tools as well. So one example, and there are multiple stages in penetration testing, and the first one is usually reconnaissance. So we need to retrieve information about the target. So we need to understand what's their attack surface, what subdomains they have, what the services are exposed, HTTP, like SSH, whatever they are. It's present on the attack surface from the target. And we had a lot of deterministic tools to do that. But now with these models, we can generate for example, word lists. And then there are more steps. We usually screenshot like all the applications. We can run some convolutional neural networks over those screenshots. Sometimes we don't actually need like LLM models to classify those images. We can use faster technologies. And then we finally try to find vulnerabilities in those applications. We try to play with the requests, usually when it comes to web exploitation or web security research, and basically, we try to find weird behaviors without having access to the source code of the target application. So in this example, I was just using like the LLM CLI to just generate a possible subdomain enumeration list for Tesla to identify their tech stack and so on. And we can generate a list like that, basically. And then one of the steps is to try to understand what subdomains exist. Like, there are passive sources with this information. Obviously, the target knows about all these subdomains, but a lot of them, or at least some of them in certain cases, are not exposed anywhere. So you need to actually guess them, and sometimes you have access to internal APIs and more. So if I just generated a possible list, and basically, I'm just trying to resolve all those subdomains with the DNS, in terms of DNS, to try to understand if any of those subdomains are resolving. And from there, we can basically just try to access those subdomains and do further testing. Hopefully, the demo gods will be in my favor. So it found 1, so I was lucky, yeah. Sometimes it gives 0, sometimes it gives 2 in this scenario, so we found like static-assets.tesla.com. And there are more examples. Another one would be FFUF AI is another tool, but to identify hidden directories in web applications. That can happen after deployment, like if we use these AI models to identify vulnerabilities in a static way, like security review by reviewing code and so on. They can catch some stuff, but the complementary approach is to do it in a dynamic way. So we want to actually try to find like hidden directories that may arise in production-only environments, and one of the tools is this one to try to brute force for such directories. And there are more use cases, but the thing here is that we still need to do all the repetitive work, running a lot of tools, all the same tools all over again. This helps on expanding the capabilities that we have, but it's not enough. So what we actually started doing and researching was on building an eggbot. And what's an eggbot? It's basically an AI system that behaves sort of like me. So it's and it can be defined. This is a definition, a possible definition from Joseph Tucker. He's a very well-known hacker in the cybersecurity industry, and it's basically defined as any augmented system that uses AI in a meaningful way in order to find vulnerabilities that mimics how an attacker would approach a given application, vibe-coded or not, for example. So there are multiple important components in such multi-agent architecture, and I'm trying to keep it simple right here, and I believe that this also applies to other types of agents, of course. One of the main components in this context is the brain. It's basically the model, is the central reasoning engine for such technology, and it's very important to try to make decisions, to test for this, test for that, and this technique and the other one. So then we have the structure. It's basically how information flows between the agents, more like engineering work, right, and not so much an AI research work. It's how we implement it in terms of using multiple libraries and so on. And then we have prompting, which is very important to give clear examples, and that's very important also in this scenario, to give clear examples of what the agents should be doing, what they should not do in certain scenarios, what techniques they can look for, and make these also extensible, like having techniques that can also be created in the fly as specialized agents, what we call also as meta agents that can be dynamically generated in certain scenarios to focus on specific tasks. And then we have the tools. Those are very, very important, especially because we are talking about ethical hacking. And we need to have tools that are capable of doing deterministic testing in multiple scenarios, basically. Thinking about like an isolated machine, like a sandbox that runs these potentially dangerous commands and is properly isolated, all right? And this really helps on trying to find vulnerabilities ahead of the attackers, and that was one of the reasons why I'm in this panel, I guess, about ethics, because we are talking about technology problem that we are trying to solve, which is also a sustainability project. We need to make technology sustainable. We are building faster than ever, so it's really important that we make sure that it's stable, that there aren't a lot of vulnerabilities, and that we can actually trust the technologies that we are providing to our users, or even the technology that we are using. Obviously, there's a common problem in most agents, which is basically about, you've probably seen multiple examples like this, like AI agents suddenly removing the developer home folder. And in the eggbot scenario, this is even more important because we are interacting with live applications, sometimes production systems, and we need to ensure that we don't damage anything. So we need to ensure that we don't drop a table, or that we don't remove a file, or that we don't change like real data that belongs to somebody else's account, for example. So in this case, it's even worse, a worse problem than just removing a home folder. And we were able to solve that problem through three main techniques, through our guardrails that basically act on the prompt level to shape the model behavior. That's an easy one. Then we have like a LLM firewall, how we like to call it, or a deterministic filter. Those are basically rule-based checks that enforce that multiple regular expressions and so on cannot be present in the outputs from the tool calls and so on. And also in the inputs, like we don't want to actually cause any damage. And then we also have an agentic layer that we can also have in certain situations, like another smaller model that is very specific to do this kind of judgment over more ambiguous cases, assess risk, and ensure the alignment with the previous goals. So I'd like you to show how this works. And I was told that this was like a demo intensive, and I freaked out and I just deleted a lot of slides from the presentation. But yeah, so I hope it all goes well, but the scenario is this one. So we have a vibe-coded application. It's like a very simple one. I asked Claude to just generate like a PHP application that allows users to upload and list and view files, all right? And the application basically looks like this in terms of the source code. So it generated basically a simple index.php. You can see like there's a download get parameter, and then there's an upload directory, and then it actually used like a secure function to basically sanitize the download parameter, because otherwise an attacker will be able like to send a parameter like download equals like .. and like read arbitrary files from the file system, even like environment variables or secrets. So it's actually using a secure function here, and then it basically just serves the file. And then there's basically a simple source code here that basically allows users to upload the files, and it even sanitizes also the HTML to prevent potential cross-site scripting issues, right? So it's like some code that seems secure, right? And if we run some static analysis tools over it and over this code, it will basically say, okay, everything seems to be good, right? So basically what we are going to do is that we are going to run our technology. In this case, we are going to run it inside Claude, but it has no access to the source code, and I'm running it inside Claude for two reasons. One of them is just because if I was going to run the actual tool, it would basically have a big output that could be not so good for demoing purposes. So we basically use a wrapper of our own standalone tool, and it will basically try to summarize what is happening for demo purposes. And the second one is that we basically we want the cloud, we don't want to reinvent the wheel in terms of trying to run the current application, okay? And like constructing the tunnel to test it in a dynamic way. So if the demo gods are with me again, everything goes well. I have a backup video in case it doesn't. So basically, it will basically just start the current application using Docker, and this is all in this case. cloud decisions, and then it just starts ngrok as a possible tunnel to serve the application to the eggbot standalone, and it will basically conduct automate or fully autonomous AI penetration testing over this application. So it's running right now. Yeah, I'll need to confirm some actions. Meanwhile, we can see the application. It's basically a file upload and view application, so we can try to upload like any sort of file there. So we could eventually like upload like a QR code. I don't remember what this QR code is, but we can download it. So doesn't seem to have any problem here. If we look at the requests, meanwhile, the eggbot is doing its job in the background. It's currently crawling the web application, it's using a headless browser to try to get all the paths from the current application, what endpoints exist, even from JavaScript files, and so on. But it conducts this reconnaissance phase. And basically, we just need to wait until it finds like a potential vulnerability or more. So if we look at the requests from the application, we can basically try to understand how it works. So here I have a post request with like a PNG file, and basically if you try to download it, you'll see like a request to get download and then the name of the file, right? So one of the things we could try, meanwhile, it's doing its job. One of the things we could try would be to basically upload, for example, a PHP shell, right? So we could basically upload a user-supplied, untrusted PHP source code and try for it to execute, which would lead to RCE, right? And the eggbot is basically coming to the same conclusions on the left. Like critical discovery, it's not so critical. We like it to hallucinate sometimes. It will try like to read the ... which is secure, but it doesn't have access to the source code. You can see also some files from the eggbot. But long story short, if you basically send a request and you try to access shell new.php, what you're going to see is that there's the actual PHP code. So it doesn't execute, right? So it's probably secure, or is it? So let's wait for the eggbot to finish its job. So it's trying HTML uploads with XSS. It's trying the same PHP file upload like a human pen tester will try. It's actually uploading a file with the PHP info command right now. So it's trying to upload an HTML file that could lead to cross-site scripting at the same time. PHP files are accepted, but it just downloads them instead of basically executing them. And then it just found like a critical discovery. The uploads directory is exposed on deployment. And what it means is that we can directly access the uploads folder and basically try to access such file, all right? So it will basically just find a remote code execution in this very simple example that basically allows any user to upload arbitrary files and execute arbitrary commands on the target application. In the meantime, it just found like a cross-site scripting stored cross-site scripting as well. So we can basically just navigate to the uploads directory and visit this file. So XXS executed and then a cookie. So this is basically the output of the JavaScript that has been uploaded. Usually we could see an alert box in there. And basically it's trying to upload more files like test.php and so on, and it will actually find the RCE in the meantime. Not sure if it already found it because it focused on XSS. It can happen. The agents do a lot of different techniques in multiple runs, but I'm pretty sure that it will find it meanwhile, but for demoing purposes, we can just navigate to the PHP shell and execute arbitrary commands as an attacker, right? So this was an example of what this kind of agents can do. It also found that we can also upload an SVG that will actually execute JavaScript as well at the same time through the uploads folder, which was a creative one. And And yeah, the demo gods just put like a window in here. All right, I was able to escape it. And yeah, that's basically it. You can really help on testing applications dynamically so that you can fix those vulnerabilities before going to production and before the attackers actually try to use this. So we basically wrap this in our product. It's not like available as such a CLI right now. It was just for a demoing purpose. But in our product, basically our agents are continuously testing the scopes of our customers and trying to find those vulnerabilities before the bad guys do. So that's it. I hope you learned something new, and I'm available to take any questions. Thank you.
Sure.